Hello, this is where we left off last time. I gave you a suggestion that try your hand at finding out how many solutions you could get for 22 nights, or for 30 nights, or for the odd numbers like 19. Would there be any? Because the ones we had were all even numbers. 28, 32, 36. Of course, the amazing thing was that for 21, there was not just one correct answer. We don't know. But for 20, there were 14 correct answers. In other words, there are problems which have multiple solutions that would work. I said that I would show you the solutions that I got, and these are the results that I got from actually working at it a fair bit of time. So I realized, and my apologies to you for giving you such a big suggestion of trying to find the numbers for all those. That I realized that was a big problem, and I thought maybe I won't give you this time, because let you continue to work at it. But the nice thing about the video is that if you got interested in trying to find, okay, how many can I find for 19, and then moved on to how many can I find for 20, and so forth, that you could have as long a time as you want. It's not like, say, in a classroom where 40 minutes and up you got to go, or you have this is the test and you've got to answer all these questions in this amount of time. You can take as long as you want on these in this series of puzzles, and or stop at some point, go to the next one in the series, see it, maybe get some insight as to how to answer something here, come back and work on this. You could come back to this at any time. Let's say you got sick and with a cold, and you could, hey, I remember those problems and I haven't worked at them very much. I'd come back and work on those now. Okay? So, keep in mind that I know there are no solution, that the total here is not 13, but I don't know that the total here is more. I don't know what the maximum totals might be. I think I have them, but I may not. Whereas having gotten as high as 17, I know that the total's not going to be 16 or 15 or 14. So anyway, let's move on to looking at some problems today. And there's a little connection between what we've been working on with what I'm going to suggest for you. These problems come from long ago, old-time problems, and I knew about them long before I knew about the King's Hunting Lodge problems and Scheherazade. And to do these, wait a minute, Larry, you're probably saying, come on, Larry, man, what you giving me that again for? You just playing with me? Well, yes, this is an attempt to play, but this pattern, which the problem I'm going to give you today, I was reminded of it because of the King's Hunting Lodge problem with this shape. So, to do this problem, this is the first of maybe a dozen or so problems dealing with something called magic shapes. And one of the most commonly known of the magic shapes was one called magic squares. So this is the simplest of the magic squares, and it's usually done by putting the numbers 1 to 9, and I have made the little ones on paper so that as I do this, and if I don't have it right answer, I don't have to go and erase and everything. I just merely slide the number around. So I'm just going to, so that's how I do it, and that's how I shared it out with students. I gave everybody an envelope and we worked away at it like that. And so now, there we are. So the question is, how can these be magic? There's actually only one solution that I know of for this problem. And the problem is, if I add these three numbers up, the sum, the total of the three numbers, must equal the total for these three, and this column, and this row, and this row, and this row, and the two diagonals. So I'm sure you're looking at the numbers and right away saying, well, what you've got there now is not the right answer, Larry. I can tell you that, and you're right. Because this row only equals 8, 13, and this one equals a whopping 15, 24. So obviously, well, I got the two smallest numbers here, and I got the three biggest numbers there, and some pretty good sized numbers coming this way. So this is 18. So I need to distribute them around differently, and next time when we go to look at the solution for this, we'll talk about a couple of the things that might give you insight. But rather than me giving that to you at this point, I'd like you to play around with this. There's so much to be gained from just playing, trying. You know, I'm gonna try. So I'll switch those two, and I better get this one away from down there. It's so big. Maybe I'll put it up here, and then I move. Oh no, I still got a huge number here. Let me put this over here. Oh, let me put this one over here then. There's an idea, and then that one, and see what I get, and so forth. So just play around with the numbers, okay? So that's that one. And the next one, well, I only need for this one, this is a magical triangle, and so I only need 6 numbers. So I'm going to use the numbers 1 to 6. I hope I can remember to tell you a little something about that for next time, too, about the numbers that we're using. I might forget. What did I say? I need a 6 and a 5. And this is just a little example, and it gives you an idea that what you're trying to do. Here I've got 12. Here I've got 12. Oh, here I've got 7. And so working it around, moving the numbers, and until you get a solution for it. And until next time, have fun. And when you're finished or frustrated, and well, tune into the next episode and see how this one worked out. And the nice thing is, I'll have a number of episodes there for you so that you can move at your own pace. You don't feel like people are rushing you. Nobody sitting next to you who's working on this and you're still working on that. You're working at your own pace. And that's nice. So enjoy, and see you next time.